Uh, Hello there. So today we'll solve some again problem and we are resuming our work of solving this on the YT. So I will try to cover all the score papers and the GTA papers happened like earlier. So this is three questions which we'll solve in this video. Like this question is I guess there is no need to solve all the but we still will. It's quite simple. And okay. So this question is also quite important, the first problem. Important in the sense like there are multiple possibilities in this way this question has in the examination. So what we should do is we should understand this particular term, that is the y by x. Right, y by x. So there is a particular curvature which is given, and what is it saying key, like let's say this is only random curvature of this particular plane. This is that curvature. So maximum and minimum of y by x we have to calculate, right? Maximum minimum y by x we have to calculate. So what does it signify actually? Apart from you are converting this equation in something like a parametric form, you are writing on this curvature. So it's not like practically feasible also for this curvature. You can write the parametric form. If it is circle like x square plus y square equal to r square or some hyperbola sort of this one or like ellipse as well. So then you can find, of course, the x and y coordinates in terms of theta and the t parameter. But for this particular picture, I guess it's not also feasible. Okay, so you should understand the second approach to solve this kind of questions. Like this format is not generally y by x. This format can be anything like y minus y naught upon x minus x naught. This particular format. Okay. So what we should think is, let's say this is our x and y axis particular, and we are choosing any particular point on this curvature, right? This point will be x comma y because we are varying the upper point, right? So this particular slope of this line is the y over x, isn't it? Slope of the line is the y over x. That particular slope, right, of any point connecting these two points. So, and this is the like this is our other second thing, like y equals to this one, right? So this particular line is varying, but so the extreme cases, right? Extreme cases particular when this particular line will become tangent. Like in case of circle, we have so any particular point will be y x comma y particular. So the maximum of y by x or the minimum of y by x will be at the extreme cases, tangent cases, right? This is the y by x, this is the y by x. So this particular is the minimum and this is the maximum. Clear? Okay, that is the thing we have. So for this particular this part and this part, I mean this line and this line, what I should do is I should put the like y by x as m. Let's say this is the maximum and minimum value, and this I will substitute in my original equation y equals to m of mx. Fine. And what I know is that this particular line is not tangent to this curvature for which cases? Boundary cases. For this, but of course, this line is not a tangent, right? But for the maximum and minimum cases, right, this line will become tangent to this curvature. Okay. Let's say in this question they were asked to calculate the particular maximum and minimum value of the m. And I mean y by x, right? So this boundary cases will be what? The extreme cases, and that is the maximum and minimum value. Right? So for few values of m, this will become tangent, and that will be the maximum and minimum value of the y over x expression. And this can be any particular format, right? This format. So you have to do the same thing. Assume it as m, and correspondingly put the value of y there. Got it? And put the and you obtain a what? A quadratic equation, and that d should be what? That d should be equal to 0. That you have to do. Okay. So let us proceed to the calculation part. That is the like conceptual part, which is the standard way to this kind of calculation. Now just try to solve. Okay. So y is what? Y is mx. So this will be 2x square plus x into mx plus 3 m square x square minus 11x minus 20 mx plus 40 equal to 0. So I am getting the x square into m plus 2 plus I mean x square into 3m square plus m plus 2 3m square plus m plus 2 minus 11 plus 20m into x plus 40 equal to 0. So d should be 0. So 11 plus 20m whole square, that is coming out to be 4 into 40 into 3m square plus m plus 2. So 121 plus 400m square, 11 to the 20, it is 220, 440m should be 160 into 3, 480m square plus 160 into m plus 320. So I'm getting the 80 m square, 160, 440, and 160. 8, and this will be 3 minus 1, 2. So minus 280, minus 280 m, and plus this will be 320 minus 120. So 9, and this will become what? Again 102. Just a minute. I guess it is 189. 10 minus 9, or 11 minus 12. 99, I guess. What I'm trying, एक सेकंड, ये भी नहीं आता यार. उफ, 320. Okay, fine. 129. So it, what the values of m we are getting? ये factorize भी होगा कि नहीं होगा? Just a second. Fine. So I guess in this question, they're not asking the integer value of the maximum and minimum. They're asking the sum, right? And the sum will be what? This will have root m1 and m2. So m1 plus m2 will be equal to what? This will be 280 by 80. This will be 7 by 2, I guess. Fine. There's no need to solve. It's 7 by 2. Okay. Fine. Now this question. So regarding this question, you should be able to understand how you can create the 6fx, right? It means x cube got differentiated 3x squared, then 6x, then 6. And this got integrated 3 times. So simply, you have to apply the by parts. First thing which I'm observing. Or apart from that, applying the by parts, you can observe this particular result. Like we can use this little timing. X into f dash x plus fx. This I know is what? This integration is actually what? X of x. So if I will just try to understand this particular, how we can use this in this question. So 0 to 1, x cube, f triple dash x plus, this is derivative, like this is the derivative. So this f double dash got differentiated. So here x cube got differentiated, 3x square into f double dash x. I should add this particular two. Now what I should do is this one is x cube into f double dash x derivative, right? Now subtract the minus 3x square into f double dash x. Fine. This thing is there. Now that differentiate this particular 6 into x f dash x. Now add this particular to 6x into f dash x. So you can easily observe x cube as it is, f double dash got differentiated. X cube got differentiated, f double dash as it is. 3x square got differentiated there, and f dash x got differentiated there. Right, this there. Fine. And accordingly 6x f dash x plus 6fx we have. Fine. So now you can easily form the pairs. So that's how you can solve it faster than to use the by part 3 times, right? So you can easily avoid this thing, f double dash 1. So now this thing is what? The first term will become x cube into f double dash x derivative. Basically, I have added the conjugate derivative part, you can understand, right? And that's how I make a pair. Fine. From there, it is coming x cube into f double dash x, this pairwise, and minus, it would be 3x square into f dash x. And accordingly, this will be a 6 what? 6x fx. F got differentiated and then x as it is, I mean x got differentiated, then f as it is. So final answer is x cube f double dash x minus 3x square f dash x plus 6x of x. This is the function. Integrate from 0 to 1, and that is equal to what? That is equal to f double dash 1. So finally we are getting the f double dash 1, because at 0 all will become 0. So f double dash 1 minus 3 f dash 1 plus 6 f1, that is equal to f double dash. This one got cancelled. F dash 1 is equal to what? 2f. F dash 1 is 2f. Fine. F dash 1 is 2f1, and then f dash uh, f dash x minus 2f1. I guess it should be f dash 1 is 2f1. So I guess यहाँ पर f dash x नहीं, f dash 1 होगा. Okay, there's a misprint there. So it is f dash 1 minus 2f1 will be there. Fine. So now this will become what? This will become 0. So option A is correct. Fine. Okay. And now this question, the image of this particular point I have to calculate. We can solve it very fast. 3 comma 5 image I have taken the line what? X minus y plus 1. So like in advance also there are few questions that's quite easy. So to solve the accuracy. And this was the like in this paper this was the that question. And these two were the unique concept if you not know this one earlier. So like this the extreme cases of tangent one you can imagine. And accordingly in this question particular also you can solve using adding the part of derivative which is needed to make it the exact differential. So that's also concept we can keep in mind. It will solve like it will improve your solving part. Okay. So 3 comma 5, let's say this particular point is h comma k. Then I can write for h minus 3, k minus 5, and upon 1 minus 1 should be equal to h minus 3 k minus 5, that should be equal to minus 2 into 3 minus 5 plus 1 over 2. This one cancel. H minus 3 should be equal to minus 2 plus 1, minus 2 plus 1, minus 1 into minus 1, that is minus 2 plus 1, minus 1, okay, 1. And k minus 5 should be equal to minus 2 plus 1, minus 1, multiplied by minus 1, that is 1. So h should be equal to 4 and k should be equal to 6. So the image will be 4 comma 6. Now we can check the options. So you have to put so let's start with the last one, 0, that is 2, that is incorrect. That is 0, 6 plus 2 square, that is also incorrect. It is again 2 square plus 2 square is also incorrect. Now this one, 2 square plus 4 square. I guess no one is coming then. Uh, I guess here we have the negative, I mean positive thing. So it should be minus 1. So k should be 4. Fine, k should be 4. Okay, sorry. So as I said, solid accuracy, and I'm going to do the mistake. Okay, fine. This one is incorrect, and I guess this one is correct then. Let's check the left options also. 2 square and and 2 square is incorrect, and 0 then also incorrect. So fine. It's B is correct and this one also is correct. Fine. आगे बढ़ते हैं next part में और लेते हैं. Okay.